Find the inverse of the function y equals negative root x plus 3. And I'm just going to switch x and y to get started. Great. Now I'm going to subtract 3 from both sides of the equation. So we're going to have x minus 3 equals the negative root of y. At this point, I just want to get rid of this negative, so I'm going to multiply both sides by negative 1. So this will cancel out. And here we get, that looks like x minus 1, but it's just times negative 1. So negative 1 times x is negative x, negative 1 times negative 3 is plus 3. And that's just equal to root y. Great. Now I can square both sides to get rid of the radical. So y is equal to 3 minus x squared. I like to put the positive one first. It doesn't really matter though. You could have written the answer as negative x plus 3 squared. But we will have a domain restriction in this case. And why is that? Because if we take a look at the range of y equals negative root x plus 3, that will have, this function has a range of y is smaller or equal to 3. And I'm going to show you graphically why later. For now, I'm just going to restrict the domain right away. So say that the domain for this function would be x is smaller or equal to 3. So this is the inverse function of y is equal to negative root x plus 3. So let's take a look at that. If I'm going to graph this guy, the negative root of x plus 3, we're going to start here over at 3. 3 and 0, that is the, sorry, I meant 0, 3, and that is the y-intercept. And it's a radical, but it's going down, so it's going to take this shape right here. Over here, that's going to be 9 over. So take a look at this. Okay, I think that will be good. Yeah, well, it's supposed to go through this point though. Didn't quite, my line didn't quite go through it. But that will do the job. So that is y is equal to the negative square root of x plus 3. And the graph goes down forever, basically. It looks like it sort of converges here, but it doesn't. It goes down forever. And so the range of this is just y is smaller or equal to 3. That is the range. And to find the domain of the inverse function, we're just going to take the range of the original, switch the y for an x, and that is the domain for the new one. So let's take a look at that graphically as well. I'm going to start by just drawing the y equals x line here. Great. So if I were to just blindly graph this guy, the full parabola, you would have the two sides, right? And that would be incorrect. But let me do that anyways to show you guys what not to do. And let's just start with the vertex of this parabola here, which would be 3, 0. So let's start right here. And there we go, that's good enough. And then it's going to go up. If you don't understand why it's taking this shape, I'd highly recommend that you go down to our website and take a look at quadratics, because we have graphed several of them and we discuss them on the videos. Okay, let's give it a try. Good enough. What about over here? not too bad. But so here we are, and this is the full graph of y equals 3 minus x squared. However, as you can see, that is twice, and you should go through that point. That's kind of bugging me. It's twice this graph, right? So our actual solution needs to get a restricted domain. So we need to say that only this part here is actually the solution, or rather the inverse for our function, which is y equals 3 minus x squared, given that x is smaller or equal to 3. So that's 3, and x is smaller than that. And this part is just going to get ignored for the inverse. So none of the orange part anymore, just the red. And that's it. This is our inverse.